Welcome all. This video is about types of chopper fed DC drive. There are 4 different types of chopper fed DC drive. Type A chopper or first quadrant drive. Type B chopper or second quadrant drive. 2 quadrant drive, that is type C and type D. Then we have 4 quadrant type or type E chopper. We are going to discuss one by one in depth. At first, type A chopper fed drive or first quadrant drive. This type of chopper is shown in this circuit. It is known as first quadrant chopper or type A chopper. When the chopper switch is on, V0 is equal to Vs. As a result, the current flows in the direction as shown here towards your load. When the chopper switch is off, but I0 continues to flow in the same direction through the freewheeling diode FD. Thus, the average value of voltage and current, say V0 and I0, will be always positive to operate the chopper in the first quadrant. In type A chopper, the current flow will be always from source towards the load, as the average voltage V0 is less than the input voltage Vs. Next we have type B chopper fed drive or second quadrant drive. In the second quadrant, current is negative whereas the output voltage is positive. In type B or second quadrant chopper, the load must always contain a DC source E. When the chopper switch is on, V0 is 0, but the load voltage E drives the current through the inductor and the chopper switch. L stores the energy during the time T on of the chopper switch. When the switch is off, V0 will be more than that of the supply Vs. Because of this, the diode D2 will be forward biased and begins conducting, and hence the power starts flowing through the source. No matter the chopper is on or off, the current I0 will be flowing out of the load and is treated as negative. Since V0 is positive and current is negative, the direction of the power flow will be from load towards source. The load voltage will be more than that of the supply voltage Vs, so the type B chopper is also known as step-up chopper. Next we have a 2-quadrant chopper drive, first type, that is type C chopper fed DC drive. In type C chopper, the current will be of positive as well as negative, whereas the load voltage is always positive. Type C chopper is obtained by connecting type A and type B choppers in parallel. We will always get a positive voltage at the output as the freewheeling diode is present across the load. When the chopper switch is on, the freewheeling diode starts conducting and the output voltage V0 will be equal to Vs. The direction of the load current I0 will be reversed. The current I0 will be flowing towards the source and it will be positive regardless the chopper is on or the freewheeling diode conducts. The load current will be negative if the chopper is on or the diode D2 conducts. We can say the chopper and freewheeling diode operates together as type A chopper in the first quadrant, and in the second quadrant the chopper and D2 will operate together as type B chopper. The average voltage will be always positive, but the average load current might be positive or negative. In the first quadrant operation, that is from source to load or from load to source like the second quadrant operation, the two choppers should not be turned on simultaneously as the combined action may cause a short circuit in supply lines. For regenerative braking and motoring, this type of chopper configuration is used. Next we have type D chopper fed drive. When two chopper switches CH1 and CH2 are on, the output voltage V0 will be equal to the supply voltage Vs. When V0 is minus Vs, the two choppers will be turned off, but both the diodes D1 and D2 will start conducting. V0, the average output voltage, will be positive when the chopper switches are turned on, and the time t on will be more than the t off time, as the diodes and the switches conduct current only in one direction. The direction of the load current will be always positive. Hence, in type D chopper, the voltage V0 may be either positive or negative, but the current I0 will be always positive. Next, we have 4-quadrant chopper drive or type E chopper. For the first quadrant operation, that is forward motoring, the switch Q1 and Q4 are on. Current flows from the supply through Q1 through the motor, then reaches Q4 and then to the negative of the supply. IA and VA are positive. It operates in the first quadrant. For the second quadrant of operation, Q2 is off and diode D1 is forward biased. The current flows through D4 and D1. Current IA is negative whereas VA is positive. That is the second quadrant operation of a 4-quadrant control. In the case of third quadrant operation, switch Q2 and Q3 are in on state. The current flows from positive of the supply through Q3 through the motor, then it reaches negative via switch Q2. The current IA and VA are negative. Hence, it operates in the third quadrant. Finally, for the fourth quadrant operation, Q4 is turned off, D3 is forward biased. Current flows from negative of the supply through D2, motor D3 and then to the positive of supply. In this case, VA is negative but the current IA is positive. Hence, the motor operates in the fourth quadrant.